Somewhere in a dealership service bay, a $70,000 truck is sitting dead, not because anything broke, but because a sensor decided something might be wrong. The engine works, the battery works, the truck just won't move, and no one can fix it. Yet, the sticker on that truck read $70,000. And the repair bill? Nobody's sure yet, because the diagnostic tool hasn't caught up to the architecture. This is what happens when iron gives way to silicon, when the bones of a truck are no longer steel ladder frames, but unibody spines laced with electronics that no backyard mechanic can touch. This video is brought to you by the Durability Project, where we explore why the things we buy no longer last and the engineering decisions that quietly shape their lifespan. Somewhere between the 1970s and today, the pickup truck stopped being a tool and became a platform. And that single shift in philosophy is the reason your repair bill now reads like a mortgage payment. The body-on-frame truck is exactly what it sounds like. A steel ladder runs the full length of the vehicle, two parallel rails connected by cross members, like the bones of a spine. The cab bolts on top, the bed bolts on behind it. Everything rides on that frame the way cargo rides on a freight car. And that frame took punishment. Hard use, bad roads, rollovers, collisions. The frame bent so the body didn't have to. A mechanic with a torch, a floor jack, and a Saturday afternoon could read those bones and set them right. The repair logic was honest and physical and accessible to anyone who knew steel. Then the engineers started chasing range, efficiency, and ride quality. And the ladder frame became the enemy. It was heavy. It duplicated the structure the body could provide on its own. It took up space that a battery pack needed. So when the Silverado EV arrived, it came not as a truck in the traditional sense, but as a unibody structure. The same fundamental architecture used in crossovers and sedans, where the body and the frame are one fused shell. There is no separate ladder underneath. The shell itself is the skeleton. That is not a compromise. It is a calculated trade. A unibody lets engineers mount a massive battery floor low and flat, dropping the center of gravity and opening up interior volume in ways a ladder frame simply cannot allow. That is how you pack enough cells into a truck to deliver 400+ miles of range while still hauling a half-ton of gravel in the bed. The physics work, the engineering is sound. But that fusion carries a cost the spec sheet never mentions. When a body-on-frame truck takes a hard hit, the frame absorbs the damage. The body survives. You replace the frame section and the truck lives again. When a unibody takes the same hit, the damage travels through the entire structure because the structure is everything. There is no separate frame to sacrifice. Repair costs climb because you are no longer swapping out a component. You are reconstructing the organism. This is where the trade-off stops being theoretical. This is where it shows up on your invoice. The unibody architecture demands precision manufacturing and specialized repair equipment. It demands technicians who understand that a crumple zone pressed into the rocker panel is also a load-bearing wall of the battery enclosure. Bend that panel, and you have not just a body repair on your hands. You have a structural event that touches the battery, the chassis, and the software systems monitoring both. The Ford F-150 Lightning made a different call. It kept the body-on-frame layout, the same bones that have carried American trucks for 7 decades, and electrified them. That truck feels familiar under a wrench. Its repair logic traces back to gasoline ancestors that independent shops have been servicing for decades. The tools exist, the knowledge exists, the infrastructure exists. The Lightning isn't simpler because Ford couldn't build something more advanced. It's simpler because Ford understands something GM is betting against, that a truck still has to be fixable by the world that owns it. It is a deliberate statement about repairability, long-term ownership cost, and the kind of trust a working truck has to earn across 100,000 miles of hard use. The architectural choice, unibody spine versus body-on-frame skeleton, is the single biggest determinant of your repair bill. It shapes where the weight lives, how damage moves through the structure, and whether the mechanic at your local shop can even open the work order without a factory terminal and a software license. The Silverado EV's 350 kilowatt charging capability is not a feature. It is a consequence. To charge at that speed, the truck needs a thermal management system, a battery chemistry, and an electrical architecture that can handle currents powerful enough to run a small neighborhood. And all of that hardware weighs something. At peak charging, 350 kilowatts pushes enough electricity into that battery pack to add roughly 100 miles of range in about 10 minutes on a compatible charger. To do that without destroying the cells, the battery needs active liquid cooling running through it constantly. Coolant lines threading between cell modules the way arteries thread through muscle. A battery management system monitors thousands of individual cell voltages in real time, making thousands of adjustments per second. And the high voltage cabling carrying that load has to be thick enough that it does not melt under the current. This is not a charger. It is a controlled electrical storm, and the truck is built to survive it. But every one of those systems is a failure point. The cooling loops can develop leaks. The battery management system runs on software that can receive a bad update or misread a sensor and throw the entire truck into a reduced power limp mode, or refuse to charge at all. The high voltage contactors that connect the battery to the drivetrain are electromechanical switches that cycle every single time you plug in, and they wear down over time the way any switch does. None of these components exist in a gasoline truck. None of them respond to a standard OBD2 reader. The Silverado EV tips the scales at over 8,500 pounds in some configurations. That mass is not accidental. It is the physical weight of the technology required to deliver 350 kilowatt charging and 400-mile range at the same time. More battery cells mean more weight. More thermal management hardware means more weight. More sensors and control modules mean more weight. The truck is not heavy because anyone was careless. It is heavy because physics does not negotiate. That weight has consequences on the road and in the service bay. At 8,500 pounds, every turn produces body roll and weight transfer that a lighter truck simply does not generate. Brake components wear faster under that load. The suspension works harder on every mile. And when a sensor in the thermal management loop sends a fault code, the entire charging system can go offline, leaving a $70,000 machine sitting on a flatbed headed to a dealership that may be backed up for weeks. The Ford Lightning's charging architecture tops out at around 150 kilowatts, less than half the Silverado's peak. That is a real limitation on long road trips. But it also means a simpler thermal system, fewer high-voltage management layers, and a charging architecture that has been in production long enough for technicians to actually understand how it fails. The Silverado EV is a marvel of engineering. It is also a machine whose complexity has outrun the diagnostic infrastructure built to support it, and that gap is measured in dollars and downtime. Insurance actuaries have already done this math. The Silverado EV costs roughly $173 more per year to insure than a comparable Lightning trim, not because it crashes more often, but because when it does, the repair is more specialized, more expensive, and takes longer. The backyard mechanic who once rebuilt a carburetor on a Saturday afternoon is now standing in front of a high-voltage warning label holding a torque wrench that is useless without a software handshake from the factory. The machine sitting in that service bay is not broken in any way its builders would recognize as failure. Every component is doing exactly what it was designed to do. The problem is that the design itself has outrun the world built to support it. The $70,000 truck is not a rip-off, and it is not a miracle. It is the honest price of a machine caught between two eras, carrying a battery the size of a dining room table and software that no single technician fully owns. The latter frame gave way because range demanded it. The 350 kilowatt heart arrived because speed demanded it, and the repair bill arrived because complexity always extracts its fee. Before you sign that paperwork, ask the question the spec sheet will never answer. Now how fast it charges, not how far it goes, but who fixes it when it breaks, and whether you can afford to find out. Brought to you by the Durability Project.